Okay, so we're just going to cut right to it with a few polygon basics. You've studied these your whole life. So triangles, quadrilaterals, pentagons, hexagons, you've studied them all. And now we're going to talk about the angles inside. So there's three formulas, okay? There's formulas for when you're talking about the inside or the interior angles. And then there's a formula for the exterior angles. Okay, so first we're going to write the formulas and then we're going to practice them, okay? So with interior angles, there's two things that you need to know. If you're looking for the total of what's inside the shape, or the sum or the total, the formula is that you take the number of sides, you subtract 2, then you multiply by 180. And that's going to give you the total of the whole shape. If you want to know each angle, so this would be if it's a regular polygon, and your teacher will explain what a regular polygon is. But if it's a regular polygon and you want each angle, you can take the same thing you just did over here and then just divide by the number of sides. So if you want to make a little note, n just means number of sides. Now what about the exterior angles? Well, if you're talking about the sum of the exterior angles, that's not a formula, that's just a fact. It's always 360. But if you want each exterior angle of a, same thing as above, it's got to be a regular polygon, then you can take that 360 and divide it by n. Okay, so what does this look like in a problem? Because that's just a bunch of formulas and words right now. Okay, well here's what this would look like. Let's say that I draw this for you. And I want to know the angle measure of each angle inside. And it doesn't look like it, but what if I do that and label them all as congruent? That's going to make this be a regular polygon. Now, how many sides does it have? 1, 2, 3, 4, 5. So it's got 6 sides. So a 6-sided figure is called a hexagon. And if I want to know each angle measure, that's like this one, this one, this one, I first need to find the total. So from the formula above, it tells me to take the number of sides, subtract 2, then multiply by 180. So I'm doing 4 times 180. So in my calculator, I'm going to type that in. You may already have memorized how many it should have, but some people don't. So it's 720. Now 720 is the total if I were to add all of these little guys together. So what if I just want one of them? Well, if I want one of them, that's what this formula is for. I just divide by 6, however many sides there were. So when I go to do that, I'm going to get 120. Okay, so there's one example. So you might be asked, another way it could be asked is like, what is interior angle sum of a 16-sided figure? Okay, well if it asks you like this, the keyword is sum. It wants to know the total of everything inside. It gave you n. It gave you the number of sides, guys. So this is all you're doing. Okay, and when you do that in the calculator, we get a lot, 2520. Okay, so that just wants the whole sum. It didn't say each one, it just said the whole sum. What if it says find the exterior angle of a 23-sided regular polygon? Okay, it doesn't say the word sum, so this just wants you to find one angle on the outside. And I don't even want to try to draw a 23-sided polygon, but I'm going to go back up and look for the formula because it says exterior, and it didn't say sum, it said each one. So I need to be doing 360 divided by n. So what is my n? Well, 23. 360 divided by 23 is, what am I getting? 15.65 degrees. And that's pretty much all there is to it, guys. The only other thing I can think of is maybe working backwards. So sometimes it'll say like, each angle of a polygon is, and then it'll give you something like 120 degrees. Find how many sides it has. So if it's giving you each angle, you know, we don't know how many sides this thing has. We don't know what it looks like. I hope it looks better than that, but we don't know exactly what it looks like. But each angle's 120. So how do I work backwards, right? Well, I need to figure out, instead of dividing something, basically, let's see. If I set up an algebra equation, it could look like this, where I'm saying, okay, somehow I need to do all of this divided by n equals 120. And this is the hardest kind that there are, I guess, because what you would have to do is you would start by like multiplying that n to the other side, just using a little bit of algebra. And then from there, we would distribute or divide. I guess we could divide by 180. So n minus 2 equals 120n over 180. We could reduce that. N minus 2 equals, what is 120 over 180? That's 12 over 18, which is 2/3. And then we would try to get the ends together. Yikes, this is gross. Okay, so how would I do that? You know what I'm going to do? I'm going to cross multiply. Let's do that instead. So I cross multiply. 2n is 3 times n minus 2, and then 3n minus 6. I'm just doing algebra. Distribute, distribute. And then I'll move this n over here. I'll move that 6 over there. Whew! Whew! All right, that's as hard as they get. But, you know, hopefully you won't have to see one quite like that. But that is the algebra that is behind that math. So that's how we work all different kinds of polygons.